Okay, I had you watch the videos explaining all of the rotations and where these terms come from, and I just wanted to do a brief recap before we do a problem. Wanted to point out a couple of the same things that we see. Now we have 3 accelerations, and this one here you can just kind of think of as being the resultant acceleration of something if it's accelerating radially and tangentially. So for it to be accelerating tangentially, that means that the rate of rotation has to be changing for an object. So that it would be either speeding up or slowing down. That rate of acceleration for this thing that's rotating is what we define as alpha, and the rate at which it's rotating is omega. These guys here are exactly like the kinematics that we had in Physics 161, and just remember we were able to do derivatives and integrals to get to all of these pieces, and I'll do a video reviewing on how we can do that later. See, then moving on, this guy said this would be if I had acceleration tangentially that way and that way, then just to kind of remind you, my resultant acceleration vector would be like that away. That's just doing Pythagorean. So we come over here, and now we can relate the rate of rotation, so our period or our frequency, to omega itself. So I can either write the period in terms of 2 pi over omega, or I can say that omega is 2 pi over or period, and because period is the inverse of frequency, then I can define omega in terms of frequency. So this is handy because like the first question that I came up for you to give a go says that I have this guy here rotating at 3,800 RPMs, and it takes 10 minutes to come to a stop. So if it's rotating at 3,800 RPMs and it takes 10 minutes to come to a stop, how many, or what's its total theta? What's its total angular displacement? So pause that and see, have I given you enough information to solve that? Or what do you think we can do? Okay. So I know I have 3,800 RPMs, and I think the thing to get stuck on is if you look at all of these, you're like, but they involve the radius of something, and I haven't been given that. But I look at this, and I'm like, this is rotations per minute. Well, that is a frequency. So I know that my frequency is 3,800. Oops, let me put this up here. 3,800 rotations per minute. And I know that omega relates to that just in terms of 2 pi. So let's think about that. If I have a rotation and I go all the way around this circle that is a perfect circle, and don't challenge me on that, goes around this perfect circle, well, the way we measure that is in terms of 2 pi. So I've gone 2 pi radians all the way around. So to turn my frequency into an omega, I'm just multiplying it by 2 pi. So omega is going to be my 2 pi times the 3,800 rotations per minute. Now normally I force you to put that in terms of seconds, but I've been given a time that it takes to stop in terms of minutes, so I don't see any reason to do that conversion. So let's see. I'm going to have then omega naught is pi times 7,600. Yeah, sorry, it's doing the mental math. I probably shouldn't do that. Rotations per minute. That's my omega initial. It's coming to a stop, so my omega naught, or omega final rather, is 0. And I know the time that it takes to get to that stop is 10 minutes. So delta t is 10 minutes. In acceleration, well, it's just the same as our tangential velocity. where that was our change in velocity given an amount of time to make that change. So alpha is going to be, let's see, omega final minus omega initial over time. Well, omega final is 0, so alpha is going to be negative pi 7600 rotations per minute times, and my time is 10 minutes. Cool. So let's see, it's going to take one of those zeros off, and so I have an alpha is negative 760 pi rotations per, not rotations, goes away, per minute squared. Cool. So we have that. Okay. So you'll notice I took the rotations out. It's not a unit, so I don't know why I'm still rewriting it. But the question we wanted to know is how many radians did this go through? So I can kind of look back through my tool chest. Let's say I determined it's alpha, so I determined that acceleration. I've done everything I can with this. I know the time. So I look here. Well, if I take theta naught to be 0, just my starting point, I know omega and time, I know alpha and time, so I can find then my final theta. So coming down here then, I'll have that theta final is going to equal omega naught t. And again, I'm going to stick in terms of, of minutes because everything's in minutes, so it's just easier to do. Say I have omega naught t, where'd it go? There it is. Let's see, pi 7600 per, let's see, per minute times the time times the 10 minutes. And then we determined our alpha was negative, so it's going to be minus 1/2 alpha, which is the 7600 pi over minute squared, and then times time squared. So times my 10 minutes, and that will be squared. So there you have it. So let's just double check our units. Our minutes will cancel out here. I have minute squared here. That'll cancel out with that minutes when it gets squared. And then I can just throw that into my calculator. I get theta equals, let's see, 1.19 times 10 to the 10 to the 5th radians. So does that check out? I look at what units I have left. Well, I incorporated pi is our radians. So that is our correct unit. Times cancel out, and we have it. All right, so let's have some fun and turn this into energy, shall we?